Well, this will be interesting doing this video here downstairs watching the basketball game, and I'll try not to get too distracted here, but I want to make sure you guys had all the explanations for these 8 problems and then the ninth problem as well, number 19, A and B. And I'm going to strangle my dogs here in a second, but nevertheless, we'll get the videos done. Number 1, y equals inverse cosine of x squared. So if I were you, I would keep my inverse cosine or inverse trig derivative rules handy so you can refer to those. But anyway, y prime is equal to negative 1 over the square root of 1 minus u. Now this is the u, so if you're following the formula, 1 minus u squared. So x squared squared, I'll just write it as x squared squared. And then multiply that by the derivative of the u, and what in this case the u would be the x squared, so the derivative of that x squared would be 2x. And so we can write it like this: negative 2x divided by the square root of 1 minus x to the 4th, and that's as far as we're going to take that. Okay, number 2, y equals inverse cosine of 1 over x. So y prime then is the same thing. We're going to use the same formula. Negative 1 divided by the square root of 1 minus whatever this thing is. Now again, that's the u, so 1 over x is going to be squared. I'm just going to leave it like that. Multiplied by, I should say, the derivative of 1 over x, but I'm going to write that as the derivative of x to the negative 1, so it'll be easier for me to see it. And then negative 1 up there on top. The derivative of x to the negative 1 is negative x to the negative 2. Okay, divided by square root of 1 minus 1 over x to the 2nd power. And I suppose we could clean that up a little bit, noticing here that we have a negative times a negative. That's going to be a positive. And this x to this guy right here is 1 over x squared. So let's see, what would be the best way to write that? Maybe like this: 1 over x squared times the square root of 1 minus 1 over x squared. It's probably a really good way. There is a really good way to get that out of there, factor, but here we have a fraction under the radical. Not normally acceptable, but I'm going to go ahead and allow you to leave it like that, because there's not a whole lot of benefit to taking out that x squared, and just not a whole lot of benefit to doing that. So we're going to leave it just like that, even though in the back of the book it's probably, or in the solution key, it's probably factored and then simplified a little bit more. But again, we're just going to leave it like that. Number 3 looks like y equals inverse sine of radical 2t. And so y prime equals, just using the formula, 1 over 1 minus this guy squared. So if I, well, I'm going to have to do another step anyway. So there's our u, and we're going to square that. And then the derivative of radical 2t to the, or 2t to the 1/2. So I'm going to write it like that: 2t, I should write derivative with respect to t to the 1/2. Okay, well that's a different story. So why don't we do that over here in a different color? The derivative of 2t to the 1/2 with respect to t is 1/2 multiplied by 2t to the negative 1/2 multiplied by the derivative of the 2t. And the derivative of 2t is 2, so that you can see here that the 2's are going to cancel. And I end up getting 1 over the square root of 2t. Okay, so that's what this guy is. So this is right there. And alright, so I guess that's about all we need. That 1 over radical 2t means that we can put the radical 2t down there, and I'm going to go ahead and leave it like this. Not politically correct to leave it like that, but I don't mind. Radical 2t quantity squared is just 2t, and fine, just leave it alone. just like that. Okay, that is the derivative, pretty as it might be. Alright, y prime here, y prime equaling, again, 1 over 1 radical 1 minus u, which is 1 minus t, quantity squared, multiplied by the derivative. We can do this one in our head. The derivative of 1 minus t with respect to t is just negative 1. And so 1 times negative 1 is negative 1, and I'm just going to leave it like this, 1 minus t quantity squared, and we're going to leave that alone. Okay, that's number 4. Number 5, y prime is equal to, now again, we just use the formula, radical or absolute value of u, which is 2s plus 1, multiplied by the square root of u, which is 2s plus 1 squared, minus 1, and then we're going to multiply this by the derivative of 2s plus 1. And when you get a function like this, you have to assume that y here is a function of s. Okay, so it's okay to assume that. As we see here that this derivative right here is just 2, and so we can just, not a whole lot we can do with this denominator here, so we're just going to multiply the 1 by the 2 in the numerator and then just rewrite everything in our denominator just the way we see it. 2s plus 1, quantity squared, minus 1. Okay, that's it. Nothing fancy, we're just using the formula. Okay, the formula provides you with your directions, and just if you could just follow the directions, everything will be fine. Y prime here is, let's see, sorry, I had to look at the TV. It's 8483 Memphis. Secant inverse of 5s, or inverse secant of 5s. So the derivative of the inverse secant is 1 over the absolute value of 5s multiplied by the square root of 5s, quantity squared, minus 1, times the derivative of 5s, which is 5. And so we could cancel the 5 and the 5. Let's go ahead and do that. Let's cancel here the 5. The absolute value of 5 is 5, so we can cancel that. And then we can just get 1 in the numerator, absolute value of s, multiplied by the derivative of 25s squared minus 1. Don't you dare try to factor that and get rid of the radical. Just leave it alone. Okay, and onward to number 7. Number 7, x is greater than 0. Okay, well, y prime, using the formula, is negative 1 divided by the absolute value of x squared plus 1. Now, I'm going to write it as absolute value of x squared plus 1, but in the end, we really don't need those, because x squared plus 1 can never be equal to 0, and it can never be less than 0, so we don't need the absolute value bars. And then inside the radical, we have x squared plus 1 to the second power minus 1. But then don't forget, we also have to multiply by the derivative of x squared plus, oops, that wasn't very good, x squared plus 1 with respect to x. And we can clean this up a little bit here. The derivative of x squared plus 1 is 2x, and so we're going to multiply the negative 1 times that. Again, the x squared plus 1 is always going to be positive, and so we can remove the absolute value bars. We don't need to multiply that out, the x squared minus 1 squared. Just going to leave that alone, and that's it. I'll leave it just like that. I think I can get these first 8 problems done in one video, and then I'll take the next video to do number 19. Alright, so here we have the inverse cosecant of x over 2, and well, we haven't done an inverse cosecant one yet, have we? No, we just did. My bad. Alright, well, negative 1 over the absolute value of x over 2, and then multiply by the square root of that thing squared minus 1, and then we're going to multiply by the derivative of that thing. So the derivative of x over 2, we should know that. The derivative of x over 2 with respect to x, that's just 1/2. Okay, so we really just have here, just multiply by 1/2, because it's the derivative of x over 2. And what do we have here? Well, we could see, maybe we could see this. So I'm going to actually show a couple steps here. We'll do a little algebra here. We've got -1. You should be able to know how to simplify this. That 1 over 2 we're multiplying by, that means it's 2 down here. So 1 over 2, 1 times that. Okay, 1 over 2 multiplied this by the absolute value of x over 2. Well, that's just the absolute value of 1/2 multiplied by the absolute value of x. Okay, so I'm doing a little bit of algebra here, kind of showing every little step, so maybe it's even more confusing when you see every little step. Nevertheless, we have x squared over 4 minus 1. Okay, and I just wanted to show that so that you could see that we can cancel those 2's right there. We get -1 times 1 in the numerator, so we get a -1 up there. And we get -1 over the absolute value of x multiplied by, you know, I might as well show you how to get rid of that 4 down there. Let's do this. Let's factor out a 1/4. Should we do that? No, let's not do that. Let's do it this way. We'll have x squared over 4 minus 4 over 4. And that right there is, let's see, -1 over radical, or absolute value of x. And then here we have x squared minus 4 over, let's do this. We have x squared over minus 4 over 4, which means we can factor that out. We have the absolute value of x, and we can write it as x squared minus 4 over radical 4. Okay, which allows us to get rid of that. Have x squared minus 4 over radical 4, which is over 2. So think about this. It's kind of hard to see that, but if we write it as -1 divided by absolute value of x times x squared, radical x squared minus 4 over 2, it's just like, boy, I'm really making a mess of this. I'm going to flip this fraction over and write it like this. I have -1 times, and so this is going to be negative. Okay, so I can say, let's just do this all at once. We're going to just flip the second fraction over and use the negative up there and write it like this. Okay, x squared minus 4, -2 over that. That's probably what the book has, and that is a little bit nicer than seeing that fraction down there in the radical. And I know I left you guys with left some answers like that early on, but I figured I'd show one just in case you really wanted to see how to do that and you were really battling that. But I don't really feel like I did a great job explaining that, because I'm kind of like, alright, this is a lot of algebra, you guys should know how to do that. But nevertheless, it doesn't hurt to brush up on that. And if you work through those steps, if you really had a hard time following that, then I would encourage you to just take this radical. And as I look at this, I'm remembering that there are some times when you do actually have to do this. You have to be able to factor out that, get rid of that fraction under the radical sometimes. So you should know how to do that. If it's a multiple choice test and this is one of your answers, you should know how to get there. Okay? But nevertheless, if you left it like I had it initially, like that, on a test, I would have been okay with that. So this is just in case it's a multiple choice test, you need to know how to get down to there. So that's almost 15 minutes for those 8 problems. So I hope that helped. I'm going to do number 19, A and B in the next video. So we'll see then.